All right, let's go and get started as we review over some things. We have a quiz coming up here in just a few moments, and some of the things I mentioned it yesterday. You knew it was coming.
That was perfect.
And you're perfect. Okay, making Gavin and Brecken feel good. Okay, and so we've been talking about these ordered lists of numbers in which a rule determines what each value is going to be. Maddie, sequence, and we said that each number in the sequence is called Audrey. A term. And what is an algorithm, Audrey? Kendall, help friend?
Is it like the rule?
It's the rule that all the terms follow. So it's the rule that determines the sequence. We said that if we wanted to limit a sequence to a particular beginning and ending, we would have what's called class A, finite sequence. If it continues without ever ending, it is an. And technically, sequences are infinite unless we put artificial limitations on them. A sequence in which successive terms are calculated using previous similarly constructed terms. Those are referred to, Michael, as?
Arithmetic.
Genesis? Recursive sequence uses similar previous terms. And how would we notate, back to Michael for redemption, previous term in our algorithm?
A sub n minus 1.
Good. If we see a sub n minus 1, we know that's referring to a previous term. Now, Michael mentioned an arithmetic sequence. What is that? Abby? Help brother.
It's when, like, the recursive, but you add to it or subtract to the previous.
She kind of half got it. She also kind of went wrong on me. Someone to help Abby. You help friend. Okay, help Abby.
Okay, it's where a constant is added to like a term to get the next term.
Good. A constant, first of all, is added. And you said subtracted. Well, technically no, but it would look like subtraction class. Really, we'd be adding a negative, right? But you constantly add. So it's nothing like a recursive sequence. It just constantly adds the same value over and over again. What do we call the value that gets added over and over and over again, Abby?
The difference.
But it's the same for all of them, so it is, they all have it
constant.
in class common, so it's the common difference. There we go. Common difference is what gets added. It's the constant that gets added to every term in an arithmetic sequence. What was the formula we would use for an arithmetic sequence? The general algorithm we could use for any arithmetic sequence. Kendall? A sub n
equals A1.
A sub 1
Times, in parentheses, n minus 1 d.
Really close, but it's just plus, because we're adding this to the first term. So add the product of the common difference and one less than the term you're finding to that first term. And that's what we were doing a lot with yesterday. You can have your notes out, and we'll do a little bit of work here. If we gave you, if I gave you this algorithm, a sub n equals 1 over 2 to the n, at your seats I need the first 3 terms of the sequence. And I'll give you a few more classwork problems as well.
Do we have a first term?
You don't need it. On the first two, you don't need the first term. Those are not arithmetic sequences. These are the algorithms for non-arithmetic. Not all sequences are arithmetic. Find the first 3 terms of that sequence. Find the 6th and 10th terms of that sequence. So it's back to what we did at the very beginning of the chapter, 2 days ago. So look back in your notes if you have to. That's why you have your notes out. But you're not going to be using this formula for the first 2 because they're not arithmetic sequences.
Question.
Yes, sir.
So for the n minus 2, do you want it to be like the previous 2, or do you want it to be...
No, it's not a sub n minus 2. It's just n minus 2. It's not a sub n minus 2. So it's not 2 terms previous.
Okay.
That's why you don't need previous terms. Just a little longer to be finishing up, and then we'll take a look at these together. All right, let's take a look at these. In an algorithm, there's a very important letter, and that letter is n. What does n mean, class? The number of a specific term. If you had, for instance, the 17th term, n would be 17. If I have the first term, then n must be 1. So what is a sub 1, the first term, going to be, class? 1/2. 1 over 2 to the first. The second term, though, a sub 2, n is now at 2 because you're in the second term. So remember, n just means the term number. This would be 1/4. And then the third term would be, 1/8. There we go. 1/8. Questions on that first problem? And that's why you don't need the first term defined, because it's not an arithmetic sequence. It's just a sequence. It has an algorithm to it. Same with this one. Now this one will end up being, I believe, arithmetic in nature, but for starters, well, really, I'm not going to treat it like one. We're going to find a sub 6, we're going to find a sub 10, which means for a sub 6 class, what do we plug in for the n? 6, because that's the number of the term. And what do we get? 12. And for a sub 10, we plug in the 10, we get 24. How many of these two answers for the second one? All right, questions on basic sequences. Basic sequence, whatever the number of term is you want, plug it in for n, you're done. Okay, well, do the math, and then you're done. This sequence had to have the first term defined for you. Because we see that a sub n minus 1, Michael, we know it's going to be a...
What? Previous term.
Well, that's what this means is previous term, but any sequence that involves previous term is called a... That's what you answered last time. Genesis, help him again. Any sequence that refers back to previous terms. Recursive sequence. What is it, Michael? Recursive sequence. So here you have to start somewhere, and you have to find a chain of terms. You can't just arbitrarily find a term later. So we want the first 4 terms. We know the first term class is 3. The next term is going to take 7 minus double whatever was previous. Well, 7 minus double this class is... Then we're going to take 7 minus double this to get class 5. And then 7 minus double this to get... 7 minus 2 times 5. Negative 3. There we go. And there's our first 4 terms. You notice it's not arithmetic at all, right? There's no consistent pattern to it. It's kind of haphazard, but it's the nature oftentimes of a recursive sequence. How many had those first 4 terms for the third classwork problem? Ooh, only a couple of us. Questions? Do we not understand what it was referring to? Questions? Okay, look at the next one. 7th term of an arithmetic sequence. Okay, when you see we have an arithmetic sequence, that's where we're going to come to here. And we're looking for the 7th term, or a sub 7. Well, if the a sub 7 is what we're looking for, class, then n is 7. And the a sub 1 is the first term. Well, the first term it tells us is negative 2. And the common difference is 3. So we just plug in the values. We take 7 minus 1 times 3 plus negative 2, 16. How many had 16 as the 7th term of that arithmetic sequence? Questions on that problem? And then on the last one, it is an arithmetic sequence. There's a pattern here. How do you go from 11 to negative 5, class? A negative 6 gets added. Okay? To make sure it's arithmetic, you have to see if the pattern is the same. For instance, here you might say, oh, I see what it is. It's a negative 2. Well, is it? No. Okay, there's no consistency there. But here from 11 to 5 would be negative 6. 5 to negative 1, also negative 6. So clearly, class, negative 6 is our common difference. We can also see that the first term is 11. So the a sub 1 is 11. And since we're finding the 6th term, class, n is 6. Or you could think n minus 1 is going to be 5. What do we end up getting here for our 6th term of the arithmetic sequence? Anyone? Negative. Yes, negative 19 is correct. Took me a minute there. All right, and how many had that for the last one? Are there any problems you say, can you give us another one like, I'm going to call these 1, 2, 3, 4, 5. Are there any you say, could we do another one like this one and this one? I can do a few. Yes, ma'am. Another one like 3. Okay, anyone need another one? 5. Okay, any others? We're good on all the others? All right, do another one like 3 with a recursive and another one like 5. All right. getting some interesting smiles there. See what I did there? Genesis just got there. All right, for the 15th term, class, we need to use you could keep adding class 4 a whole bunch of times. No. So instead, let's start with our first term, 13, and we're going to add the common difference for how many times? 14 times, one less than this times. I'm not sure if the grammar there is particularly good, but one less than this times, and we end up getting what for our 15th term? 69. Again, that's a lot quicker than continue to add 4 over and over and over again and then eventually get there. How many got 69 for a sub 15? All right, now our first term in this recursive sequence is a 3, which means the second term hinges on the first term. So we need to substitute in the previous term, 3 plus 2 class, times 3, divided by 5. All right, then for the next term, we're going to have to plug in the previous term, which is a 3. And what do we get? 3. And then we're going to plug in the next, and we're going to get? 3. In other words, this is literally a recursive sequence of unending 3s. How many figured that out? You could tell by the laughs and the faces that you had gotten that. Good. Questions on this? All right, any other questions on sequences, or do we feel like we've got them? Do we feel like we're good with sequences, or we still feel a little nervous for some reason? Anything we need to address before we hand out a quiz? You'll get 100? All right, clear desk, except for a clean sheet of paper and a pencil. Gavin's screaming, wait, I have a question! Email me. Sorry, Gavin. I guess you could always pause the video if you had a question. Pause the video until you get your question answered and then take the quiz. All right, those in here, though, have had their chance. First and last name at the top of a blank sheet of paper along with today's date, which is, I still have March up here. It's 4/7/22 today's date. 4/7/22 today's date. And this is quiz 31. Quiz 31. Let's take a look at the quiz together now that Maddie has one. Let's take a look at the quiz together. Numbers 1 through 5, answer the questions. Numbers 6 through 10, follow the directions with those sequences. And then there's a bonus for you as well. I'm curious to see if you can figure it out. There's 2 ways you could approach the bonus, but we haven't actually done it yet. So this is kind of a can you figure it out kind of question. All right, go ahead and get started.